Okay, welcome and thanks for joining Jutel and 2W.com webinar for radio production and distribution in the cloud. And this is our second webinar on the topic. On the first part, my colleagues from Jutel, Jorma Kivelä and Olli-Pekka Lukkarinen will introduce the Radioman radio broadcasting platform. After that, Anke and Perry from 2W.com will present the Moin software for distribution. And then after that, we will hear Brian Wilson's experiences from radio production and distribution in the cloud from video. Brian gave a good speech in December, and we will hear that again. And then at the end of the webinar, we will have some time also for questions and answers. But now I will give the stage for Jorma Kivelä for the Jutel part.
Okay, thank you, and welcome to this webinar Jutel part. I am Jorma Kivelä. I am CTO of Jutel Radioman, and my colleague joining me here is Olli-Pekka Lukkarinen, COO of Jutel. Jutel is one of the most experienced radio automation solution providers in the world. The customers are typically national radio and commercial radio broadcasters, major ones. And today we are talking about our next generation Radioman solution that is cloud native radio broadcasting platform. With the cloud native broadcasting platform, we mean that all the broadcaster operations can be run as a service from cloud anywhere with just a browser user interface. The system supports also networked radio stations with multiple channels, and the services include planning, media management, production, layout, mixing, voice tracking, archiving, and distribution functions like distribution control, streaming services, legal loggings, etc. With the cloud-based platforms, we can start out-of-the-box thinking concerning the broadcast business, so we have lots of new opportunities. And before we are going more deeply into the functions, my colleague Olli-Pekka is going to show a short demo on some of the features in the cloud service. Olli-Pekka, please.
Thank you, Jorma. Let me share my screen. So let me start from the on-air user interface. So I'm using Google Chrome. Microsoft Edge is also supported both on Windows and Mac OS. We have also used Android and iPad tablets for controlling or running on air. But I'm using Windows in this. And on the left side, we do have a running order. And just below the running order, there is a card wall, single buttons and hotkeys. And on the right side, we usually, when we are doing a running order, we can look at media info for each song or audios. So this is the basic layout of the on-air. Going more deeply to playlist, we have an on-air situation where we are reporting, and we have also available time, which is counting. Our program is, well, in Finland now it's 8:03 in the morning. Our program is about to start 8:05 and it's until 9. Available time shows that we have 1 minute available time until the program ends. We have ability to change start type of the items. Green arrow means it will start automatically. The next symbol below it means there is a crossfade. if we look at fading tool, we can see that these two songs, we have done a crossfade here. We can modify it even when we are at the on-air situation. And we can save the crossfade. Control buttons are below the running order. Once we press go, we will start play the first song. I'm not sure if you can hear that on the line, but I believe you can.
Yes.
It is because I'm connected, I'm controlling the media node, which is in a cloud from our office right now. But I can connect to the cloud, and when I connect, the audio will be transferred to me using the WebRTC. There are virtual faders. The first one is talk, which is my own microphone. Then there is a playout where I can control my playout level. On the right side, there is the PGM metering of my playout level. Card walls, the left side, there is a card wall 1, and on the right side, card wall player 2. I can play audios from here. This will go to the specific faders as well. I can do voice tracking even when I'm on air. If I want to do voice tracking here, I will again open my fading tool. I will look the specific location where I want to do voice tracking between the two songs. I want to do voice tracking here. I will play out first. I will start my recording here, and this will record my audio track now between the first and the second song. And when I'm done, I can save the audio, and this will go to the playlist to that location. So there is my 11-second or 10-second audio. I can pre-listen it. Okay, I'm happy with that audio, so I will keep in the running order. I can also delete it if I don't like it. Search. This is connected to our database. Our database is using it's on the IBM DB2, or we can also use PostgreSQL. The latest arrivals view will show you what are the latest saves in the database. You can sort by audio, or if you want to show what songs have been saved lately or what adverts. So this is easy tool to show what has been lately saved. You can also, what songs we have in the database. For example, Red Hot Chili Peppers. Okay, we have these songs. When we are on air, there can be several persons on the different locations. So when I have now my microphone, so I'm now contributing to the program. I might have my colleague in a different location, and that can join to the program. You possibly see on the right side, there came a fader, and under the fader, there is a Sami, who is my colleague. How are you doing, Sami?
Good morning, Olli-Pekka. I'm doing fine.
Thank you, Sami.
It's a bit cold outside.
Yeah, and it is raining snow here, minus 13 degrees of Celsius, but you are doing well, aren't you?
Yeah, thank you.
Okay, thank you.
Bye.
Bye. So there can be several persons joining from different locations. We could have a talk program, or we could have a news reporter outside, and we can do a program together. And another thing is that when we are playing a song in a playlist, and if you want to talk on top of the song, you can have an auto ducking. You possibly see the fader goes down when I click talk. So you can set the auto ducking if you want to have a talk on top of the song. Then on the right side, we have a source selection. We can have a number of outside sources. Those can be at RTP streams or SRT streams, which will come from we have predefined that, for example, TV news, when we want to take the TV news to the program, we connect TV news and immediately this will come to the program and it will again goes to the BGM output.
Clicking on the top button here will create auto ducking where it will automatically adjust the microphone level.
We can also use predefined RTP streams on a running order as a scheduled event. We can have a time start, for example, exactly every hour we get RTP stream some specific location. For example, we have a news from another studio which this program can use. Or we can have a main national program and some local programs who will share content at the specific times. Okay, so this is the basic view of the on-air. There is a lot more, but we can go to this later on. And this is the planning user interface, where we have the basic view is that on the left side, we have again our database. And right now on the right side, I do have my daily planning. This is actually the program which we were running just a while ago. And this is in a list mode. We can look the daily programs or week view. There are different views in the daily planning. Playlist design. We can go more detail designing our playlist. Voice tracking is also available here in a similar way what we did in on air. So I can do voice tracking here between the audios. Done. And we can prepare our cardboard sheets here for the on air. We can do sheet settings, coloring, how many number for every sheet you have cardboard and so on. We have reporting tools available. And of course, the administrator to create user, do the profile rights for the users. We do have an audit log, playout history, and so on. All important information. I believe this was the walkthrough of our user interface, and thank you. And back to Jorma Kivelä now.
Thank you, Olli-Pekka. Now let's go more deeply into the actual broadcasting platform. The platform itself, it can be in the cloud, or it can be also as on premises or on virtual server environment, or a combination of these. The demo system Olli-Pekka was showing is situated in AWS cloud currently in Sweden, and we are running it here in Finland. The platform can support multiple radio channels, and the radio channels may be nested as a network with localized advertisements, program blocks, and so on, so that, for instance, you can have a national main feed and then localized regional programs running part of the time. And as a cloud-based system, you can have fixed or temporary studios anywhere with just the browser interfaces. Some studios may have large broadcast complexes with internal IP media networks, and the simplest form is just a tablet with a headset. And the internal structure of the system consists of different parts here. There is first the Radioman back end. The back end has a extensive data model. It contains media asset data, music data, long-term plans, daily plans, programs, lists, publishing data, recording info, distribution info, publishing info, user rights management, that kind of stuff. Also the Radioman file storage is audio files, music files, other files. And then the backend also contains different file transcoders, level, for instance, EBU R128 leveling, and all the backend architecture is based on the REST API. The interfaces here, there's lots of APIs available. There are media transfer interfaces. Naturally, there's traffic interface for advertisement, music interfaces, so that we can use either our own music selection, or we can use external third-party music selection like G Selector or Music Master. And then there's publishing interfaces, so that we can get the now playing information out. We can publish to web, we can publish to CDN site and get the reports out, and all of that. And that's pretty much about the main parts. Then we have a actual playout unit, which we call media node. The media node, it can be in the cloud, or it can be also physically in the studio, or any virtual environment, and also as a physical box. And it is the part that implements the on-air activity. It's not just a player. It performs also streaming in and out with RTP, WebRTC, SRT. It can produce web stream, icecasts, and ACLS, and so on. And with virtual audio cards, it can, if it's in studio, we can provide AES-67, Dante, Livewire, WeetNet, and within studio also analog and digital audio. And it can do transcoding, mixing and level controls, autoducks, play, record. It can also control external devices and services, and it utilizes internally active MQ messaging and WebSockets. And so we can also control the distribution and multiple media nodes, so that we can, for instance, nest them one after another, so that we can have the main channel and then the localized media nodes that get the feed from the media channel. And then if we want to have lots of distribution feeds outside, not just a couple, then we can use, for instance, the two-way MOIN for controlling the distribution streams in the system. And the streaming services we can have as a media node, or they can be run from the 2WCOM production. And then the archiving and legal locking are part of the functionality the media nodes. We can also have automatic rules for logging and those facilities. And one part of the functionality Olli-Pekka already showed is live functionality, where we can have live contribution from anywhere into the cloud and into the broadcast very easily. And just a picture of different studio installations. We can have large studios, small studios, everything connected to each other. So that's pretty much everything from now. And let's give more speech to our Barry in two-way.com.
Yes, Jorma, thank you very much. So I do my best to take over and share my screen and hope this functions. Now I have to, so I hope you see the first screen of my presentation.
Sorry, Anke, not yet.
Not yet?
Nope.
Strange. Now?
Yeah, now it's good.
Okay, perfect. So it was a double click. Sorry for that. Okay. Yeah, so thank you very much, Jorma, for introducing the Jutel Radio Man. Very interesting indeed, and we're still proud to be part of this great solution for radio distribution in the cloud. And I want to welcome our guests outside there too. Good afternoon when it's good afternoon for your time zone, and good morning for, well, the European part, for example. My name is Anke Schneider, and I just want to start a short demo and introduction of our MOIN multimedia over IP network software. Okay, so first of all, who is two-way.com? Well, we are directly neighboring to Denmark in the very north of Germany, and we are a broadcast technology-driven company. We have a very long time of experience, about 25 years, and we're not only manufacturer, but also a supplier and system integrator. So for any case, if you have a project to be deployed, we can also stand on your side as a system integrator. We are very experienced because our staff is containing 75% of engineers for development, support, and after-sales service. And well, just have a look at some people of our team. Yeah, when I look at this picture, I became a little bit nostalgic because this was the IBC 2019. And I'm really hoping that we're going to see some of you joining this webinar, perhaps this year, perhaps next year, again, live at the IBC or the NAB or any other event. Let's have a close look at the portfolio of our hardware. We have audio over IP solutions for hardware. It's the IP4C codec, IP8E encoder, and a multi-channel codec. We even have solutions for MPX over IP. Very interesting indeed, because we can generate the MPX signal and we can distribute it. And we can even distribute it not only via IP, but also via satellite. So in any case, a solution if you just want to ensure the signal is not touched anymore at the transmitter side. Yes, we have also FM and DAB solutions, a very well-known satellite series with the FlexDSR audio over satellite products. We have DAB converters, switches, and we even support for the digital radio in the US, HD radio with our HD capture client. Well, let's have a look at the software portfolio. It's all about the MOIN software, multimedia over IP network software. It is designed for studio to studio, for streaming applications and for distribution. And let us just have a close look at the whole picture, because this means that the MOIN can support up to 512 channels. And it is very designed for IP interoperability, because it supports all protocols and standards and audio qualities you need for studio, streaming, or distribution. It's even designed for flexibility and system design, because it runs on hardware servers in the VM or on the cloud. And well, yes, now it's even self-healing because of Kubernetes. I said it before, the whole picture means that the MOIN software connects just studio, distribution, and streaming. It can take all the studio streams, it can transcode it to just feed the CDN, or IP networks, or satellite distribution systems, or even to send the streams to the DAB multiplexer. And looking at what we're doing with the Radioman, we have just this simple picture, and it's clearly displayed. The MOIN software just takes the streams from the Radioman and transcode it for the needs outside, if it's just the transmitter side, the studio side, or even to affiliates. And I personally think this is enough for sales and marketing purpose, and I want to hand over now to my colleague, Barry Eskes, to go a little bit more in technical details. Thank you very much.
Thank you very much, Anke. Okay, oops, one moment. Okay, yes. Okay, let me continue. Thank you very much, Anke, for the introduction. So now I shared my screen. I hope everyone can see it. I think yes. So hello, my name is Barry Eskes, and I'm a global sales manager at 2Wcom. And let me guide you through the technical part of this webinar. So no worries. I will try to make it as simple as possible so everyone understands what we're going to talk about. So let us start at the beginning. What does MOIN mean? It does not only mean media over IP network. It's also a German word which means hello or bye or goodbye. It was originally just used in the northern part of Germany and in the southern part of Denmark. And there are also other languages with similar words. The cool thing about MOIN is that you can say it at any time of the day and to any person. Our vision behind MOIN is that we build an audio product that can talk to every codec and to any audio over IP software in the market. And that is still our vision until today, interoperability. And since actions speak louder than words, we have built in a lot of protocols in MOIN. You must not know every one of these protocols, so no worry, we're not going to ask you after this webinar which protocol is which one. But just to name a few, here's AES67, Ravenna, Livewire, SMPTE 2110, which is probably the most known audio over IP protocols. Of course, we also support DVB transport stream, which is used for satellite networks. As you can see, we have a very big list of codecs like PCM for uncompressed audio, Enhanced aptX, MPEG Layer 2, MP3, and all AEC variants. Also, the new AEC-X high efficiency codec and Opus are included. The interesting thing is that all of them are included, so free of charge, except for micro-MPX and Dolby. The reason is that we have to pay a fee for that to the license holder. Also on the management, you will find the most modern tools available. When it comes to controlling our devices, we also try to be as much as possible tied to the broadcast standards. Let us cover some basics of the MOIN, for example, the software stack. We are able to run MOIN with any number of audio channels. It really just depends on your hardware. Just to give you an idea, on one virtual CPI core, we can run around 10 stereo audio channels up to 40 stereo audio channels, depending on the codec you're using. So our worst case is 10, our best case is around 40 codecs of transcoding on one virtual CPI core. The software is available as bare metal image. That means you can install it directly on the hardware server. You can also use the same image to install it in a virtual machine or a VMware Proxmox or whatever hypervisor you choose. Or you can dive even deeper and install it on a Docker layer within one of your virtual machines, or just use our Kubernetes deployment to deploy it also into a Kubernetes cluster that you run. And since we're having Kubernetes, we can also provide Moin as a cloud service. Of course, then you can run it on premises or in the cloud. And you can choose, depending on your security measures, where you want to run this. Moin has several use cases. The main use cases are the ones Enke already has shown with Moin, where Moin for streaming, Moin for distribution, and Moin for studio. There are some corner cases, like contribution, where we can combine the signals from all the studios together. In the studio part, for example, transcoding, measuring, and monitoring. And in the streaming, IceCast, HLS streaming, which is, by the way, also done by the Jutel software. Today, we go to focus on the distribution part. With distribution, we mean distribution to your affiliates or real transmitter sites for FM and digital audio broadcasting, or even for the US customers amongst us, HD radio. As already described by Jutel, this use case is to provide a completely cloud-based radio playout. We receive a high-quality stream from Jutel. Our software is co-located in an AWS cloud to provide low latency and high quality. Our Moin has the role of sending audio over IP streams to multiple devices at studios, transmitters, or affiliates. Let us focus on the error protection methods for distribution. The latest and greatest protocol are RIST and SRT. They are both reliable UDP mechanisms, and they are working in a way that they are continuously sending UDP packets from the encoder to the decoder. Only when a packet gets lost, the decoder is able to request a packet, and only the lost packet will be resent. That is also the reason why they are called re-request protocols. It is a very nice method compared to TCP/IP, because you don't have the handshake overhead. They're not constantly asking, oh, do you have received a packet? Packets are only requested. That's also the reason why SRT is good in cloud environments, because it has a so-called caller mode. That means it can work through firewalls and call any destination and ask, hey, please send me your audio. Or it can send audio in the same way. This is a very nice secure environment, because the ports are only opened when you're calling and not opened all the time. RIST, in contrast to SRT, works with RTP and not on UDP levels, so it has all the benefits of RTP timestamping. It is possible to use multicast and audio synchronization. Both protocols providing best protection at lower bandwidth compared to forward error correction. That is a very general phrase, because in some corner cases where effect might be better, but in general, you want to have a decent protection at less bandwidth and latency than forward error correction. Moin for distribution. This works very well with our hardware codecs, like the IP8E or the IPv4C. Of course, we are committed to interoperability, so it should work with any codec from any of our competitors. AES67 and EBU Tech 3326 are very good standards to secure interoperability. But in case you have a codec which won't work, just let us know, and our software engineers will make a fix to also get your codecs up and running together with Moin. This slide shows one of the powerful features of Moin. One codec can address several destinations by using different transport protocols. This example shows an MP3 audio encoder in the Moin feeding the IP4C audio over IP codec, and at the same time feeds the same MP3 to a CDN via an IceCast in pool protocol. Using one codec for two different destinations saves you CPU load, and therefore saving you cost. What we heard a lot is the expression cloud native. What does that mean? And is our Moin really cloud native? Since it is a big buzzword, we got a bit deeper into this topic and explain what we mean with cloud native. That means it's not working super integrated with AWS. If you go into bed with AWS or one of the other cloud providers, you get dependent on either one of these infrastructures. Kubernetes points Moin in the right directions for real cloud-native software solutions. For example, we can use our auto-scaling in our cloud environment. That means that when we require CPU load, then a cluster can scale up and scale down when it's not needed anymore. This is a great feature when you're having on-demand codecs. That means less cost for cloud usage. Then we have automated DNS entries and certificates. It provides automated mechanisms to really run this stuff in the cloud with security in mind, namespaces and policies. Everything you need to run this in the cloud environment and protect that one customer interferes to the other customer as they're running next to each other. Kubernetes lets us run this in any cloud, such as Google Cloud, AWS, Azure, DigitalOcean. Almost all of them have a Kubernetes system. One more thing. When we're talking about software solutions, then we also need to talk a bit about security, because security is often a big concern when it comes to cloud environments. A couple of things we like to mention is that we're currently running a security hardening process for the project with Akiva, which is one of the service providers for BBC. They have a very tough requirements for security, and we are working hard to comply to their requirements. By now, we have automated vulnerability scans for each release, and before asking, nope, we are not vulnerable for Log4j. Our devices and software are not affected. We also have a services and firewalling concept. We support infrastructure concepts like ESD calling, which works fantastic through firewalls, and we are a member of the subgroup of the National Cybersecurity Centre in the UK. So we get first-hand information when we see big threats to infrastructures. So you can feel protected by 2WCOM technology. So that was a mouthful of technology. Now I would like to hand over the microphone to Brian Wilson from CBS News, who has worked with Jutel and 2W technology for some time. So Brian, over to you.
Okay, Mike, thank you very much. My name is Brian Wilson. I've been a broadcast engineer for about 45 years, so I've seen everything from non-computers in the broadcast industry through computers and huge hard drives and, and then, digital audio, AES, analog, and then audio over IP, and then basically us living in an IP world in the broadcast industry. So anyway, when the pandemic hit back in March of 2020, right now we're working for, national broadcasters doing national newscast programming stuff, and from a network perspective. So we feed to a satellite provider who uplinks, our programming through a satellite provider. So, and they're located in another part of the country. So initially we thought the pandemic, as everybody else did, was only going to last a couple of weeks, a couple of months. We didn't know what the deal was. So we have bureaus around the United States. So we kind of moved our operation to another bureau. And that wasn't really being hit by the pandemic. And at that point, we had anchors using IP codecs, VPN, and we're able to go back to our main studio, one of our main studios that we switched our operations to. So that looked like that was going to work in the short term, but then we realized, long term, we're going to need a solution now which was a cloud solution because it looked like things were getting shut down. People were not going to have to work from home. So we needed to find a way that we could provide the functionality for anchors and copy editors at home to match their on-premises workflow. You want that workflow to be very similar or as close to what you can do from home as you could do from your main studio. So we're able to find a web-based cloud solution that would provide all of that functionality that we needed: content creation, automation playlists, walls, so we could play our news actualities, a virtual mixer to mix everything into a good sounding broadcast. And the big fact was that this was web-based and did not provide people to actually have to load applications. As we know from a security perspective, loading applications on a company PC can be difficult. Everything has to be vetted through IPsec and a lot of other things to make sure for vulnerabilities. But the fact that this was totally web-based made the implementation a lot easier. So the products were there, but weren't there yet. So we still had to take that final mixed product in the cloud and transport it to our satellite provider, which another step, in the chain. But now that we had all the piece parts, the biggest thing we had to consider now, end-to-end latency. When you're dealing with the IP transport packets, it's IP latency. So we first worked with measuring that latency from the anchor's home to the cloud and through the cloud software application, and in each step we looked at what data rate we were using, what algorithm we were using for each part of the process, because we wanted to have the required audio quality, but then we had to measure to see if the latency was acceptable. So it took many reiterations and a lot of testing, down to hundreds of milliseconds for each part of the process as we were looking at to see where could we cut down latency, even if we got a tenth of a second, a couple of tenths of a second there, a couple of tenths of a second there. As you start adding that up in the chain, you can make your overall latency, a little bit more desirable. But we started to find as we continued our testing that when you do these tests, you want your latency at least to be predictable. And then we found that, depending on how long a connection was up and stuff like that, we were finding now that latency was not consistent and not predictable. So that started to make things a little difficult. So we found some solutions for that. And so that we were able to take that cumulative latency, within the cloud and, kind of make it, somewhat acceptable. So we got it to that point, but then that was only through the cloud, to our cloud system. We had our last part of our chain, which was to take it from the cloud and then send it to our satellite uplink provider, which was located in a little part of the other country. So once again, we had to test that link for latency, and because if you've got this great cloud solution, but your last mile isn't robust and reliable, then it's really not a workable solution. You really have to have a full end-to-end solution. So initially, we were doing this via an MP3 RTP stream, and that worked okay. But the reality is long-term reliability was an issue since a stream like that really has no error correction. So then we looked and we found the solution then using Opus with SRT as the transport protocol. And this actually has been proven to be a very reliable transport protocol, with its use of ARQ. And as Leif mentioned, you get the benefits of TCP in your UDP stream, making it, more robust and reliable. But of course, that benefit of reliability is offset with some additional latency, since for ARQ to work, you must add a little bit of an additional buffer delay to allow those retransmission of lost packets. So you really needed to work that trade-off of reliability and latency. And of course, as all the engineers in broadcast will know, that is your constant trade-off dealing in the IP world, reliability and latency. If latency is not an issue, then you don't really have to worry about that. But when you're dealing with real-time audio and you're trying to hit posts and stuff like that, you really have to take latency into consideration, in your flow chain end to end to make sure that it's going to work and it's going to sound smooth. So we continue to test and make fine tuning at that point until we finally got to what we would be considered, an acceptable latency. The good thing is, as it was mentioned before, is that, you can take these streams and do other things with it. And the idea is like, can you take content and somehow use that content for other streams and make other new revenue streams with the similar content? So you've got a single piece of content, but now you've got multiple revenue streams. And that's the key here. So with our cloud solution and SRT transport, where we're able to take that same newscast content, but then replace the commercials with different ones that we from our organization can traffic. So we can now create traffic schedules from a traffic software, merge it into the cloud with an automation playout schedule. So now we've taken that with another player, and now with the new Opus and SRT transport stream, we were able to bring that back into the cloud, mix it all up again, and now send out a new stream. So this allows us to leverage that same newscast content to add additional revenue to that stream. So the key to all of this is that the solutions now has given us the ability to originate anywhere in the world. I mean, typically prior to COVID, we did newscasts from our main studio, wherever that be, in New York, Washington, since we're US based. But now we particularly have people doing it at their house, doing it while they're on vacation, or if they're reporters that have to go to other parts of the world. We've had people do it from Southeast Asia. We've had them to do it from Mexico. We've had them to do it from Europe. And they're actually able to do their live newscasts from a hotel in a conference room where we could secure, a good space that was going to be quiet. And with literally a PC and software, a PC, and just logging on via the web, being able to fully produce broadcasts with that broadcast quality and latency that is sounding good. So that's really the big thing here. You're no longer tied to what I call the old school way of originating your backhaul at your main studio or bureau or whatever to get your content to the satellite provider. The last thing about this is that this all sounds really, really great. You don't have to be at your main studio anymore. You can originate anywhere in the world, make it sound like you're at your own home studio. But the problem is your main studio has certain resources that your home studio doesn't have. That might be power, internet. You really don't have to worry about air conditioning and stuff like that, like you do at a studio. But the biggest two things that we saw were power and internet. At the home, you're at the mercy of your power company, and you're at the mercy of your ISP. Most people don't have dual ISPs at home. Obviously, in a lot of these broadcast solutions, if you've got a critical link, all of the vendors pretty much provide you now with dual ISPs to do dual streaming. So, you won't go down, hard from that particular point. But if you're at home, what do? So basically what we found is that for most of our major players that are a part of our network, we've provided a UPS for them. So now, they have a UPS that they will put their broadcast equipment through. So if there is a power hit, in most cases you're talking power hits. Sometimes you will lose power totally, but you'll take power hits. And of course, if you've got everything going through a UPS, and you don't need a huge set, you don't need, half a room of UPS batteries, but any commercial thing where you can take a power hit or be able to stay on the air for a couple of hours with a decent sized UPS. And then the other thing that we've actually put in Anchor's homes is cellular internet. So this way, if your ISP goes down, some people do have two ISPs, but that's still not super 100% reliability. If a pole falls down and they're both coming through, a cable modem, even if you got a cable modem and a DSL or something, they're probably on the same pole getting close to your house if you live in a neighborhood. So that could take you down. So we have a cellular internet connectivity that they have at their house. So if they do lose internet, they can just switch over to cellular delivery. And, since we're talking about audio and not video generally, the bandwidth limits, are pretty small. So the cost factor isn't huge there. We don't use the cellular full time, we're only going to use the cellular. We keep it on so we know it's always working, and we can check it everybody's house to make sure everything's good. But we actually only use the data when we have to. So they can just switch to cellular. Once again, log on onto the web, get onto their software, do their newscast, and be back in business. So it's really opened up the possibilities really now of anybody really broadcasting from anywhere, and not the traditional, everybody's got to be at a major city or wherever your business has to be located. So but it took a lot of, I got to admit, it did take a bit of testing. A lot of these solutions do work really well, but you do have to fine tune them. The more you understand about how they work, the easier it is to kind of fine tune and try to find the little hooks to save, like I said, save 10 milliseconds there, save 50 milliseconds there, and save maybe 100 milliseconds there, depending on your algorithm, data rate, and stuff like that. So you can fine tune it to make it work for your broadcast. So now you can sound professional audio from somebody's house, and it to sound timed and sound really good, and once again sound reliable. So a lot of these solutions, that have come up in the last 2 or so years, have really improved the reliability and to really open up the new door for broadcasting. I mean, I can't see a lot of organizations going back to having 50 people, at a bureau anymore. I think it's definitely going to continue in a hybrid mode, where some stuff might be done in a studio that's super complex. Other stuff will be done, at other locations and stuff like that. I really think that is basically the future of broadcasting. And part of it will be cloud, some of it will be on premises. And the idea is that you have both, so you can leverage both of them, the on-premises stuff along with the cloud stuff. But if something happens, I mean, we've all been in disaster recovery scenarios over the last 20 plus years. This is basically disaster recovery. You can do stuff from your house now and not be in a main studio office. So that's pretty much the end of my presentation, and I'm really glad that the vendors have come up with really great solutions for us to continue to broadcast.
Okay, then we have some time still left for the questions and answers. There is a Q&A available in this Zoom application. You can use that if you have any questions, or I think you can also raise hand, and I can share also the ability to speak in this webinar also. So any questions?
If I, Jorma here, if I comment a little on the delays and that kind of stuff Brian Wilson talked about. When we were testing with the WebRTC connectivity from over the common internet, what we found out is that naturally in the common internet, the delays are varying from time to time and also from different locations. And as we are controlling also the playout, not just the speech via the internet, what we ended up is that we actually embedded the control also inside the WebRTC stream, so that if the WebRTC takes a bit longer, the play button command comes synchronized with the speech, so that we can get really a fluent presentation. The delays with the Opus, what we tested where we got it takes about 20 milliseconds within the PC for Opus coding and that kind of. Then the connectivity between the PC or browser and the servers in the cloud, we took about 120 milliseconds when the round trip delay ping was about 55 milliseconds from Finland to Ireland, where we at that time had our AVS installations. And the servers in the cloud, they took about 20-30 milliseconds. Then we tested so that we got actually WebRTC also back to the studios, so that the overall delay from the microphone to the listener's ear with the two WebRTC trips between was about 330 milliseconds at that time. And from a play command it took about 160 milliseconds to the listener's ear with the WebRTC connectivity. With SRT, we can get much lower delays in distribution, but it depends very much on whether you are doing the cloud broadcasting very flexible way, so that you can have your studios anywhere, anytime, or whether you are starting to play with fixed studios connected to the cloud and so on. So it actually depends quite a lot on the total configuration. So that's comment about Brian's tests.
Thank you, Jorma. And now a couple of questions from Leif Saarela. How Radioman Cloud works over satellite links where the latency is over 600 milliseconds?
If I answer that, typically the satellite connectivity is on the distribution side, where the latency doesn't affect, because the listener doesn't know whether it's real time or 600 milliseconds back. If you are doing internet connectivity via satellite with 600 milliseconds, you can actually, I think you can manage the programming, playout, and so on, but you must be quite slow in your motions, so that you don't start tapping a rock concert or something like that. But I think for reporting and that kind of stuff, it could be used also on the production side. We have not actually tested so long delays on the production, but in those cases, what I would recommend is that we could actually place the media node, one media node in the local laptop and utilize that for the jingles and that kind of stuff. So there are ways.
Okay, thank you. Another question from Artem Lutsky. What hardware tool need to have out of the studio side, for example, at home for streaming with cloud solution?
You need a standard laptop with a browser and then some audio interface. The easiest audio interface is a USB headset with microphone and earphone pieces, or you can have a simple USB mixer, for instance, a Rode Procaster.
Yes, Jorma, a couple of words also. I worked with that Brian Wilson at 2020, so they used both Roadcaster and Focusrite Scarlett, and then of course laptop or Windows machine with the browser. That's enough. And we are using WebRTC to transfer our contribution.
Thank you. Okay, are there any other comments or questions? We have just a little time remaining in this webinar.
And if you have any further questions, please just send an email or contact Jutel or 2W.com.
Yeah, we are happy to answer. Okay, I think we are closing to the end of the webinar. I thank all the panelists from Jutel, 2W.com. Thank you for waking up so early this morning, and all of our attendees. Thanks for your interest and looking forward to hearing if you have any questions by email or other way contacting me. Okay, thank you.
Thank you very much, Marco. Thank you very much, gentlemen.
Thank you.
Have a good day.
Thank you.
Bye-bye.
Have a good
Have a
day.
good day. Bye-bye.